You ever stop and think about the hidden science behind, well, pretty much everything? Your morning coffee, the clean water you drink, even the phone you're holding. It all comes down to one basic idea: the science of separation. Today, we're going to dive into the amazing ways we sort the world around us, from the simplest things in your kitchen to, yeah, even the cosmos.
So let me ask you a kind of weird question. What could making a simple cup of tea possibly have in common with building a massive skyscraper? I know, it sounds like a riddle, but the answer is actually this really cool scientific principle we use all the time, probably without even realizing it. And the answer is separation. Seriously. Whether you're straining tea leaves to get a smooth drink or a construction worker is sieving out big pebbles from sand, you are doing the exact same thing. You're sorting matter based on its physical properties. It's that simple and honestly, that powerful. Once you start looking for it, you see this simple act of sorting everywhere. But that brings up a really good question. Why do we even bother? I mean, why go through all the trouble of taking mixtures apart? Well, it turns out there are some very, very important reasons. It's funny, the book this explainer is based on has this great character who asks this exact question. And it's the perfect question to ask. Why do we need to separate stuff? It's not just about being neat and tidy, it's about making things useful, making them safe, and sometimes making things possible in the first place. It really all boils down to three main ideas. First, you want to get rid of something you don't want, right? Like finding a little stone in your bag of rice. Got to get that out. Second, sometimes you want to separate two different things that are both useful, like when you churn milk to get creamy butter and buttermilk. And third, you do it just to get something ready to use, like straining out tea leaves so you can actually drink your tea. So let's start with the most basic, the oldest separation method there is, the one we all know how to do, just using our hands. This is all about sorting things based on what we can see and feel, obvious differences in size, shape, or color. You could call it humanity's original sorting algorithm. And this is what we call handpicking. It's perfect when the stuff you want to get rid of is easy to see and big enough to grab, and you're not dealing with a giant pile. You know, like picking a piece of onion out of your salad, or like you see here, getting little stones out of green. It's simple, it works, but it definitely has its limits. Because what happens when you're facing this? We're talking hundreds of bundles of wheat stalks, each one holding thousands and thousands of tiny little green seeds. There is no way you could handpick every single one of those grains. It would be literally impossible. So yeah, we're gonna need a much better solution. And that's where a technique called threshing comes in. This isn't about being careful and delicate. This is all about brute force. Farmers literally beat the stalks against a hard surface, and that impact knocks the heavier grains loose from the lightweight stalks. It's a brilliant, low-tech answer to a huge sorting problem. Okay, so even after all that threshing, you've still got a messy pile of grains all mixed up with little bits of stalk and husk. This is where we get even smarter. We bring in a couple of simple but powerful partners, the wind and the sieve. Now we're starting to use the laws of physics to do the work for us. Look at this. This is such a great example of using nature as a tool. By just letting that threshed mixture fall from up high on a windy day, the breeze is strong enough to carry away all the lightweight junk, the husk, while the heavier, valuable grains fall straight down. What a perfectly neat pile. It's absolutely genius. And that elegant process has a name. It's called winnowing. The whole idea is just using air, whether it's a natural breeze or a fan, to separate things based on their weight. It's just an amazing testament to human ingenuity, turning a force of nature into a precision tool. All right, next up is a tool I guarantee you've used before, the sieve. And what's so wild about sieving is its incredible range. The exact same principle, separating things based on how big their particles are, is at work when you're sifting flour for a cake and when a crew is building a highway. And you can see it right here. The scale is completely different, but the science? It's identical. You've got a mesh with holes of a specific size. The smaller stuff falls through, and the bigger stuff gets caught. It's just a beautifully simple and effective way to sort things. So we've used our hands, we've used the wind, and we've used simple tools. But what do you do when the impurities are super fine, like tiny dust particles mixed in with your rice? You can't pick them, and they'd fall right through a sieve. For that, we turn to another incredible separation tool, water. This process, sedimentation, is something you've probably done a million times without even thinking about it. Every time you wash rice or lentils, you're using sedimentation.
You add water, you swirl it all around, and what happens? The heavier rice grains sink to the bottom, while the lighter stuff, like dust, floats up. That sinking part, that's sedimentation.
So once all the heavy stuff has settled to the bottom, the next logical step is to just carefully pour off the water, right? That's called decantation. But as anyone who makes loose leaf tea knows all too well, it's never quite perfect. You almost always get those last few annoying bits of leaf in your cup. For a really truly clean separation, we need something better. And that better method is filtration. Think about it. A tea strainer, a coffee filter, even really fancy filter paper in a science lab. Filtration just uses a barrier with tiny little holes that are small enough to block the solid bits, but still let the liquid flow through freely. It's the secret to getting a perfectly clear result.
All right, now we get to what feels like actual magic. What if you need to separate something that's totally dissolved in a liquid, like salt in water? You can't see it, you can't filter it, the salt particles are way too small. To solve this puzzle, we have to actually change the state of matter itself. This is how people have been harvesting salt for thousands of years. They trap seawater in these huge, shallow pools, and then the biggest free energy source we have, the sun, does all the work. It gently heats the water, causing it to evaporate. It turns into vapor and just floats away into the air, leaving behind these incredible crystalline fields of pure salts. So, evaporation is simply the process of a liquid turning into a gas, and it's the perfect technique for separating a solid that's dissolved in a liquid, especially when all you really care about is keeping the solid that gets left behind.
Okay, time for our final, ultimate challenge. Let's imagine a scenario that seems almost impossible. You've accidentally mixed a bunch of fine salt and sand together. How in the world could you ever get them apart? Well, the brilliant answer is to combine a bunch of the methods we've just talked about.
So how do we solve this puzzle? Let's walk through it. Step 1, we add water. The salt disappears, it dissolves, but the sand just sinks. That's our key difference. Step 2, we carefully pour off or filter that salty water, and boom, we're left with clean sand. Step 3, we take that salty water and we boil it. The water turns into steam and vanishes, leaving behind pure salt crystals. And here's a cool bonus step. If we were to capture that steam and cool it down, it would condense back into perfectly pure water. Just like that, using a few simple steps, we've separated all 3 parts. So, from your teacup to a skyscraper, the science of separation is absolutely everywhere. We've seen how these simple, elegant ideas are the basic building blocks for huge, complex industries. The next time you see a giant factory or a high-tech lab, just ask yourself, deep down, what simple act of sorting is making all of this possible?